Yo, 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 Algebra 1, how's... I'm sorry. It's Mr. Knight, once again, acting a fool. So all is well, all is normal, my vitals are checking out just like normal. And let's continue on from yesterday. Yesterday we graphed equations of lines, which is more or less review. Today we're going to actually use them for something a little bit, okay? So what I'm going to do right off the bat is I'm going to make two random lines on this graph, okay? I have equation 1, and I'm not even going to look, I'm just going to do that. It's pretty good, all right? And now equation 2, I'm just going to do one of these. I hope I hit the paper. Is this the paper? Let me see. Okay. Hey, that was pretty good. Okay. So I drew these two lines, and, well, if I have two lines that are, like, continuing on forever and ever and ever, even if they, like, the blue one started way down here and the red one started, like, way over here, they're lines. They're going to continue on forever and ever and ever. So what does it mean when these lines actually cross? Like, right there. What does that mean? What do you think that means? I want you to actually pause the video and think about it just for a second, and we're going to come back and kind of explore this idea a little bit more today. Okay? So pause the video, please. Now, go. All right. Let's talk about this for a second. Okay? Well, we know they're crossing at this point, and a point can be represented as x, y, right? So we have an xy point that is shared between both of these guys right here. It's kind of interesting. I don't know. Let's see what that means. So if you printed out the notes, that's awesome. I had a note sheet that you could print out. But if you didn't, that's totally fine. You can follow along on a separate piece of paper and just kind of get the main ideas across, right? I would write your topic, level 2. I would write, you know, your little subheadings, like what a system of equations is, like what that means, right? The types of solutions, so on and so forth, okay? And then obviously you're going to get your examples. So let's start off with this. We're talking about systems of equations. That's what Unit 5 is. And a system of equations is just two or more equations with the same variable. They share an x and a y typically, okay? And if we look at both of our equations, they're just general equations, right? I didn't even tell you what m and b were for either of them. But they both share an x and they both share a y, right? And if you look, they absolutely do share an xy right here. Huh. So, that's actually our solution right there. That's our solution to this system of equations. If I know what the x variable is, and I know what the y variable is, I'll know what that point is, I'll know what x and y need to be to make these equations, well, true, right? So graphically, the point xy, that's where the two lines cross or intersect. And if you see the point xy, well, that's our answer right there. It's our system of equations solution, right? It's a solution to it. Algebraically, though, the point xy, which you could not really see with these yet, but we will see as we continue on with them, it's what x and y have to be for both equations to be true, for like 3 to equal 3 or 8 to equal 8, right? That makes it true. So those are the two ways we can use variables in a system of equations to see if, well, we're actually solving them, right? We solve them by finding what they have in common, okay? Whatever the x and y are. And we have types of solutions when it comes to graphing, right? We saw the first case earlier on where we have intersecting lines, okay? There is one solution and one solution only right here. That is my x comma y. That's right here, x comma y. That was a big boy Sharpie. It was kind of hard to fit in there, but x comma y is going to be our one solution. Well, now we have other types of lines. We have parallel lines. We have this line going on forever and ever and ever. We also have its buddy chilling to the side of it. It's parallel to it. And are they ever going to intersect if they continue on forever? Well, if they both have the same slope and everything, they're never going to cross, so there's actually no solution. That's called the null set. That's kind of a symbol we can use for it. You could just use that to say no solution. Now, what if they're the same line? What if this line is like, I'm doing this thing, but then in the background, I'm going to use a dotted line for this. In the background, there's another line that's like, hey, that looks pretty fun. I'm going to do exactly what that guy's doing. I'll have what he's having. That's an infinite solution. Because it really doesn't matter what point we pick on the line. They're always going to be, that point's always on both lines, no matter what. Whereas here, there's one point that's shared between the two lines. And after that, the lines kind of do their own thing. And then the parallel, they never share a point. Well, that's so sad, right? They never get to have that joy of having a solution. It's just no solution, okay? Now, when we're solving by graphing, there's three things we can do, okay? There's 3 steps to success, okay? The first thing to do is, if you have to, change standard form to slope-intercept form, okay? You don't always have to do that, but sometimes you do. And we're going to see some problems where you have to do that, okay? The second thing is you're going to graph both lines. Graph both linear equations. Because it's a system of equations, so we're going to have 2 or more equations. We're going to be sticking with 2, okay? But it can get complicated. And then the last thing is you're going to identify the solution. Okay, identify the solution x comma y. That's what we're after, right? Again, if they fall into either of these 2 categories, we're off the hook. But here is what we're really, really looking at. So for number 1, we're going to do this one together. And I'm going to give you a chance to try one on your own. Okay, so number 1 is y equals x minus 8 for the first equation, and then y equals negative 2x plus 1 for the bottom equation. All right. Let's use different colors. I'm going to use red for the top equation. I'm going to use blue for the bottom one. That way we could just differentiate a little bit better, okay? So let's start with the red one. Y equals x minus 8. Again, we're all going to be using y equals mx plus b. That has not changed. I'm going to start with my y-intercept, right? Well, my y-intercept in this case is negative 8. So I should expect to see the point 0, comma, negative 8 on my graph, right? So I'm going to plot that point first. 0, negative 8 is going to be 1, 2, 3, 4, 5, 6, 7, 8 right there. Okay, that's my first point. To get the next one, I have to use my slope, my rise over run, in order to get the next point. Well, my slope in this case is, well, I don't really have one, or do I? Well, if there's no number in front of this x, it's implied it's a 1. And so 1 is our slope, and I can write that as a rise over run, 1 over 1. So all I'm going to do is I'm going to go up 1, and then I'm going to go to the right 1. Okay? Up 1 to the right 1, up 1 to the right 1, and I could continue doing that on and on and on. But I got the gist of what this graph is doing. Okay? Let's move on to the other one. Let's look at the second one. We have y equals negative 2x plus 1. Again, my first point is going to be 0, comma 1. That's my y-intercept. So 0, 1 is right up here. My m is negative 2. And to make that a rise over run, I'm going to plop a 1 underneath that. So my rise from this point is down 2. And then I'm going to go to the right 1. Down 2 to the right 1. And I could just keep doing this, kind of see what's going on with this graphically. And let's go ahead, let's sketch our line. Okay. Now, your hand might not be as steady as like me. My hand's not steady at all. So kind of what I was doing was I was just applying the slope over and over and over again, right? Down 2 to the right 1, down 2 to the right 1. And you can keep doing that if that helps you kind of get a better idea what the shape's going to be. And it's nice because you want to be able to see where they're intersecting, okay? Now, if we look at this guy pretty close, we can see that, well, they intersect right about here. It looks like right about here. So what is that point right there? That is, if we find that point, and I'm gonna mark it in black so it's a little bit easier to see. If I mark that point, that's gonna be 1, 2, 3, 4. No, 1, 2, 3, 4. 4 for the x, comma 1, 2, 3, 4, negative 5 for my y. And that's my solution. That's all there is to it. I found what my x-coordinate needs to be, my y-coordinate needs to be, where they intersect. And we found it right there, okay? Now I want you guys to give the second one a try, doing just what I did. And you can use mine as reference. I want you to try and graph both equations and then find where they intersect. And go. All right, we're back. Let's take a look at what we can do with this guy. Let's start with the first equation. Again, I'm going to write it in red and try to make it a little bit more thin. You called me fat, Mr. Knight? No, sorry, equation, I would never. We have y equals 1/2 x plus 9. That means my first point is going to be the y-intercept. That's 0, 9. So 0, 9 is way up here. Okay. I'm going to use my slope, 1/2. My rise over run is 1 over 2. So I'm going to go up 1 and to the right 2 for my line. And there we go. I kind of have a good idea what's going on. I could go the other way as well, right? If this is going up 1 and to the right 2, I could go the other way. I could go down 1 and the left 2. Because -1 over -2, well, that's still positive 1 over 2. So I can definitely do stuff like that, okay? Bend the universe to your will, ladies and gentlemen. Do not be afraid to do that. Oops. Class is over. You can stop watching the video now. No, don't. I swear. Okay. That's our first line. Second line is we have y equals -x plus 6. Again, our first point is going to be 0, 6. So 0, 6 is 1, 2, 3, 4, 5, 6. And my slope is, well, now it's just a negative in front, so that is a -1 over 1 for my rise over run. And so I'm going to go down 1 to the right 1, down 1 to the right 1. I can also go the other way. So that negative, remember, the negative means either the top or the bottom has to be negative. They both can't be. So I'm going to instead go the other way. I'm going to go up 1 to the left 1, up 1 to the left 1, and there it is. I think I found it, guys. So it looks like it's this point that's like right here. So that looks like it's -2, and then comma 1, 2, 3, 4, 5, 6, 7, 8. All right, so it looks like -2, 8 is our identified solution. All right. So I think the hardest part is still, just getting your equations with lines down. Okay, so if you need more review on that, please review that. We have a couple more that I wanna touch on, and we'll go a little bit faster. Okay. I want to spend some time making sure we have a good foundation on that stuff. Let's look at number 3 together, and then I'll let you try number 4. Okay. The reason I want to go over number 3 is because now we are back in standard form. Okay, these guys are in standard form, so I got to convert them first. So if I have -3x plus y equals 8, again, I need to get rid of the ax term. So in this case, I have to add 3x to both sides. And so I'm going to end up with y equals, I can't combine, so I have to do 3x plus 8. And then I get to divide everything by what's in front of y, which is 1, which is not going to be helpful. So we're good with this guy. That's our first equation. Let's look at the second equation. -x plus y equals -2. All right, again, I got to get rid of this x term, so I got to add x. I'm doing the opposite. So then I'm left with y equals x minus 2. And again, I can go ahead and now I can graph that guy. All right. So I'm going to use the same color now for time's sake. So this first one, we know 0, 8 is our y-intercept for this guy. 0, 8 should be about there. And I have a rise over run of 3. So 3 over 1. So I'm going to go up 3 into the right one. 1, 2, 3 in the right one. I can also go the other way. I can go down 3 and to the left one. -3 over -1, so positive 3. Okay? And that line is going to continue doing that for quite a while. Hallelujah. This guy right here. First point. Y-intercept is 0, -2. And my slope is 1 over 1. So I go up 1 to the right one, up 1 to the right one. I could also go the other way. I can go down 1, the left 1, down 1, the left 1, down 1, the left 1. I can continue doing that. The reason I wanted to do that was because, well, we want to see where they intersect, right? We haven't gotten that far yet, so we got to kind of keep going with our slope in order to get these points or these lines to cross, so we could see what point they intersect at. So I'm going to continue on with this slope. No big deal. I'm going to go down 3 over 1. I'm going to go down 3 over 1, and finally I'm going to go down 3 over 1, and it looks like it's right about there, right about here. And what is that point? It's not the easiest to see, but we're going to try. I'm going to do -1, -2, -3, -4, and then we're going to go down -1, -2, -3, -4, -5, -6. So it looks like it's -4, -6. And that is the solution to our equation. Okay, I would like you guys to try number 4 on your own. Convert this guy, the top one, to slope-intercept form, because that guy's in standard form. We can't do that. And go. All right, we're back. So if you got this guy to slope-intercept form, you should end up getting, it should be y equals, off the top of my head, why can't I do math right now? Should be -1/2 x, and then plus 2. Yeah, that should be it. Yeah, we're good. Okay, that guy, and then I have this guy below it. I have the other equation, y equals -1/2 x plus 2. Now, they are the same exact equation, it turns out. So without even graphing it, and we could, but without even graphing it, we know they're going to be right on top of each other. So my solution is infinity, just like our notes told us to do. Okay, not too bad, not too bad. Now let's do one more. Let's do, I know it says number 5 and number 8. I know number 5 is the one I'm going to do, and then you're going to try number 8. Let's just look at number 8 together, okay? It's nothing different. I mean, we have something in standard form, but I do also have something that's just x equals this. If you look at this one, we have y equals this. If you recall, those are horizontal and vertical lines. So on your notes somewhere, on your notes, maybe include vertical and horizontal lines, okay? So for horizontal and vertical, horizontal, those are going to be y equals a. Y equals a, that's just the form of it, whereas vertical lines are going to be x equals a. You're like, what's a? A represents the intercept. Right? So for example, like if we're looking at number 8, like we were going to, if I have x equals -2, well, that's of the form x equals a. So -2 is going to be the x-intercept of this guy. So if you think about an x-intercept, that's where it crosses the x-axis. So the point has got to be -2, 0. That's where this line, this vertical line, is going to cross. Okay, and it's vertical because it's of the form x equals a. Okay, if it was like for number 5, that is a horizontal line of the form y equals a. And the the y-intercept is going to be the -7. So we should expect to see 0, -7 as the point we start with on here, and it's going to be a horizontal line. Okay, so that's kind of the difference. They kind of flip-flop. So x is x-intercept, y is y-intercept, if that kind of helps. All right. But let's plot this guy. So -2, 0 would be right here, and once again, it's going to be a vertical line. We got this guy below it, this equation right here, that we're going to have to change into slope-intercept form. So again, if I have 3x minus 2y equals -18, I have to get rid of the 3x. So the opposite is subtract 3x from both sides. And I'm left with -2y equals -3x minus 18. Divide everything by -2. And we end up getting y equals positive 3/2 x plus 9. All right, that was a lot. Okay, so now 0, 9 is our first point for this guy. And our slope is 3 halves. So we can go up 3, 1, 2, 3. We can also go to the right 2. It's not really going to help us too much because we want to see if the lines cross this way. So I can go the other way. I can go negative and over a negative. So I can do negative 3 and over negative 2. Boom, there it is. What is that point where they cross? That is negative 2, comma, 1, 2, 3, 4, 5, wait. 1, 2, 3, 4, 5, 6. Okay, I want to make sure I counted correctly. Negative 2, comma, 6 is our solution to that guy. All right. Good luck on your homework. Let's get some more practice on this stuff. It's new. It's difficult. Don't feel discouraged if you're having a hard time with it. Just ask for help.